My name is Alexander Karpa. I taught 18 years as a school teacher in St. Petersburg, Russia, and then as in teacher education, and wrote some books for teachers and for students. And then I started teaching in the United States at Teachers College, Columbia University, and that's what I'm doing now. Thinking about, I would probably try to contribute to discussion and to some questions about which were raised last time, but I can't help but saying a few words about Russian mathematics in general. And I believe, for me, I thought what I think was the most important, at least in my generation. And I would probably say, not just there were many mathematicians who were produced and all these things which we all know, and even not the great problems which were developed. But I would say that Soviet mathematics, school mathematics, was in a sense optimistic. I mean optimistic that basically it was somehow understood that people can learn it, and people, not that nobody failed, of course many people failed, but that people can learn it. I'm now observing the process from the point of view of a father. My son just yesterday took an exam in the college in calculus, and the family was just trembling. It's such an important thing. And indeed, there were 46 students started. Only 8 came to the last exam. And all of them were really afraid. And so what are they? You can ask whether my son is particularly weak. No, I think he's okay. And whether it's something terrible, what are they doing? They're doing basically the program which was done in my Herzen Pedagogical University at second semester. First year, second semester. So how did you guys manage to make it so terribly difficult? And that's basically some understanding that it's more or less okay, and that's how it goes. And children are supposed to be afraid of mathematics. Saying that, I do not want to criticize everything in American education, saying that they are bad. Not at all. There is a lot of great things. But I think that in Soviet Union there was some belief that people can do it, and many people did it. Now, moving to the question of problems, there was a problem, there was a question, can we develop a system of problems on some other material, right? I do not remember exact words which were there, but something like that. And I believe it's very interesting. I think, of course, the answer is yes. But we need just to recall how it was historically. Yes, we know now that we have in our Russian tradition, we have some fantastic collections of problems. Famous collection of Rybkin in geometry, or some other. Yes, it was a great idea, and in a sense this was transformed later and used and so on. Can we develop something like this? Yes, but remember that Rybkin emerged not at the very beginning of teaching. And when you open textbooks of 1860s or 1850s, there is nothing like this. There is nothing like that. And I cited in my presentation, in my topic study group, some great St. Petersburg teacher nicely wrote that he believed in giving problems for homework, although it's not a problem solving per se, because nobody solves problems and nobody can solve problems at home. Everybody is using help of tutor. But it's still useful because they learn and so on. So the idea was that school problem is something also that you cannot do it. You can memorize. But step by step, by developing, basically the system became broader. And more people got involved, and more results were necessary. And, sorry for citing classics of Marxism-Leninism, I will cite Engels, who wrote once, "The time called for giants, and giants came." So when it became necessary, people developed something. And we need to develop, we can, if we will have conditions to develop things like that. But my last words are that it's very difficult. And I have an experience as an author of a textbook when offering some problems connected with elections. And what seems to be easier, you have tables of preferences. This number of people votes for this number of people votes for that, what can happen, how can, a lot of, you see, it's very basic. Theoretically, we'll say that it's a first-class student can, well, second, can do it. But it was terribly difficult for teachers. Teachers said, no, nobody can understand it. And it's required, because it was unusual. And it required a lot of work and a lot of, let's say, patience before teachers started saying, oh, that's so easy, everybody can do it. So my answer to the question is yes, but it needs a lot of work and it needs a lot of conditions. Not unusual, not unexpected answer, but I believe the answer which is correct. Thank you.
Okay,
yeah. Yes.
You said that the experience with Russian problem books and geometry are kind of unique. But there are perhaps other collections of geometrical problems like Dieudonné.
No, I'm not saying that it's quite, that it's absolutely unique. Adamar is much more difficult. Yeah. And let's say, well, we all know the great collection Dieudonné and Zhytomyrsky, which is, but the idea was not to be like Rybkin, to be more challenging, more interesting, and most welcome. Let's do it but let's think from the position of regular students, and we need to understand that we will never have great students if we don't make foundation. So Rybkin managed to do it somehow that basically students can do it. My own last quotation from my favorite mentor. When I came to school, I had fantastic teacher working there, Aron Maizelis. And Maizelis once joking said to me that kids somehow understand whether the problem is from Rybkin or not. And if it's not, they cannot solve it. And indeed, Rybkin did maximum of how you can do for very regular student, let's say like that. So that's what I believe is extremely important. Yes, in some other countries, yes, there is experience like that too. Yes.
Question?
Disagree.
Rybkin was written.
Said it?
Rybkin was written to study geometry.
Yeah.
Dieudonné, no.
Probably.
Rybkin had complicated problems.
Yeah.
Only very simple,
Yeah.
but many applications of geometry. It's very, very important and useful for study.
And the ladder, you start with easy, then it becomes a little bit more challenge and things like that. Yeah.
It is not connected with Leninist.
No.
The people who created the system of Soviet education, they are much more clever than our people.
Well, it's a strong statement. No, but when I cited Engels, with all my respect to him and Marx, I do not want to make it political. No. Okay, thank you. Okay, you need not be afraid that I'm going to come and say something every time after everybody who makes a comment. Just couldn't help but say a few words. First, I really enjoyed these pictures. Thank you, and I'm sure kids are very happy with that. At the same moment, I need to say that some principles which were mentioned, they are more or less classic. When I was a student, I was taught about all these things that you need to represent in different ways, and you cannot simply say a plus b squared equal a squared plus 2ab plus b squared, but you need to show it in different ways, and all these things, so it can be done differently. Also, what I wanted to say, I had a great opportunity, I once interviewed a very important German mathematics educator, Heinrich Bauersfeld. I don't know whether Yes, German colleagues are here, but they of course know him. And what I particularly like, I like many things, but what I particularly like, his story about his childhood. He was taught with some very good system of addition numbers, with some elements, with some pictures I will not describe, but every time he added numbers in his mind, and then he pretend to do it like they wanted from him. So I want to say that people are using different approaches. But I wanted to connect this with the issue of motivation. And I think we have here a very interesting question. What are the reasons of decline in motivation to study mathematics? And I believe that to think about it, not that I have an answer, but what I want to say is that we need to look broader, because the issue is not with mathematics. The issue is much more general. We want children to think in school. I personally agree. I once heard very important St. Petersburg mathematician Dmitry Fadeev who was saying, look, mathematics is the easiest subject in school. I absolutely, completely agree with him. History is 10 times more difficult. Not to say philology, which is unbelievably difficult. But we observe this process of not thinking. And I would say in many ways, it's not about, here it's about drill and practice. Well, meaningful work is not meaningful and boring, it's clear. But very often practice is, I would agree with Kushnirenko, practice is very often a way to be motivated, to understand better what is happening. And, but I would say that we need to develop these discussions of what is understanding. Let me give one very simple example, not mathematical. We have a monument near Dam Tor Bahnhof. And it's devoted to very dramatic events when the children who were yet allowed to leave, Jewish children who were yet allowed to leave Germany while parents were not allowed. So the departure of these children. I would say that it's a great piece of art, but it's very clear. However, if you spend 15 minutes there standing, you'll find that many people, German, foreigners, they do not understand what is there. They do not look at this with a lot of work which is done in Germany about Nazism. But you'll see funny games around these children. You'll see kids embracing these kids, or parents playing with this. What is happening? They do not think. And it's probably because if you start and say, look guys, what is happening? Do you know what is it all about? They will never do like that. No, it's not about moral things. It's about understanding. So I would say that we need to have the question broader. What should we do to return to school the value of understanding in all subjects? Sorry if I took too much of time.